Geometric mean, all right, is used in investment actually, and it tends to be different than arithmetic mean or arithmetic average. And it's also used when people are trying to calculate like the growth of bacteria. And this is how it's used in real life. You're also going to be using it for similar right triangles. Pretty much what it is that you have an x on both. That same x is common. And what you're going to end up doing is you're going to cross multiply. When you cross multiply, you end up getting the following cross products. X squared, x times x, is equal to AB, right here. All right, so these are your cross products. And then in order to solve for x, what you're going to do is you're going to take the square root, because the square root is the inverse of you squaring something, and you get the square root of AB. I want you guys to remember that you must simplify radicals. We want exact answers, unless otherwise told so. So let's try it out with number 1 and number 2. And these are going to end up giving us perfect squares, so it'll be nice. All right, so find the geometric mean of 45 and 5. The way I'm going to do it is 45 x, and then 5. You can set it up this way, or if you want, you can also put the 45 here and the 5 on top. Honestly, it doesn't matter which one, because multiplication is commutative in this. So we're going to cross multiply, and we get x squared is equal to 45 times 5. Now, 45 times 5 does get you to 25. In order to solve for x, we have to undo that square, which means we're going to take the square root of both sides, and we get x is equal to the square root of 225. Square root of 225, if you remember your perfect squares, is 15. And that's your final answer. So now you can do the same thing here. I'm going to set it up for you, and then I want you to pause the video and check your answer. You can set it up this way, or you can set it up this way. Whichever way works for you, you're still going to multiply the same. All right, pause the video and then check your answer with me. Okay, when you guys multiply, you should have gotten x squared equals 144. Take the square root of both sides, and you get x is equal to the square root of 144, which is really just 12. And that's your final answer. It's really that easy. Now, what ends up happening is when you get numbers that aren't perfect squares. So for example, what we're going to get from our cross products on number 3 and number 4. But don't worry, all you're going to do is simplify your radical. So same thing, 4 and 12, x on the diagonal. And we're going to get x squared is equal to 4 times 12, which is 48. I need to take the square root of it. And you get x is equal to, well, the square root of 48. Well, we know it's close to 49, which is 7 squared, but that doesn't mean that this is not 7. So what we're going to do, and if you need to, you can do the tree method, or you can do the perfect squares method. So the tree method, to find out and how to simplify this, is the square root of 48, and get the prime factorizations of it. So 3 times 16, 3 is a prime number, you circle it. 16, you can split that up into 2 and 8, or whatever other factors you get. No matter which factors you use, at the end of it, your prime factorization will still be the same. So I've got 2 times 2 times 2 times 2 times 3. So it's equal to the square root of 2 times 2 times 2 times 2 times 3. Because we are working with square roots, meaning 2, we're going to find any pairs, okay? So 2 of the same number being multiplied. So I've got one set of 2's that's going to go out and another one. If you've had me before for Algebra 1, remember, couples go out, singles stay in. So you've got 2 times 2 on the outside and the square root of 3 on the inside. So you get x is equal to 4 square roots of 3. If you guys are ever having to type this in online because you've got an assignment online for me, I will usually tell you how I want you to type it. On some platforms, you are able to type 4 square roots of 3. On other ones, you might not be able to. So I might tell you to write 4 square root, SQRT, 3 with no spaces. Whatever it is, I will tell you what it is that you need to do. And sometimes I might just ask you for the actual approximation. So I want you to try this one. We're going to set it up. There we go. When you cross multiply, you get x squared is equal to 15 times 45, which is 675. And x is going to equal the square root of 675. That's a lot of numbers. I know that I can divide it by 25, though. Okay, and 25 is a perfect square. So I know that it's the square root of, so 25 and 27 right there. I can simplify this one to 5 and 5. This one is 3 and 9, 3 and 3. So you end up getting 3 times 3 times 3 times 5 times 5. Couples go out, and singles are going to stay in. So you get 3 times 5 on the outside and 3 on the inside. So you're going to get x equals 15 square roots of 3. All right. Sometimes it might even be easier for you to think about it as the original number. So say I had kept it as the square root of 15 times 45. So I could find the prime factorization of 15 and the prime factorization of 45. And notice that I would still get the same exact prime factorization with 3 times 3 times 3 and 5 times 5 right here. So it doesn't matter how you work it, do whatever works best for you. Thanks for watching.